Hello Internet, today we have a new problem to solve. Given an array of integers, return the indices of two numbers that add up to a specific target. Here is the problem statement. Given an array, write a method that returns the indexes of two such elements, sum of which is equal to a target. For example, in the given array, the indexes 2 and 4 add up to a specific target of 20. We can do this in three different methods. First one is brute force. As you would understand by the name, this is a brute force method in which we just iterate over each element of the list twice and find a combination to see which one of those elements add up to a specific target. So you can see we have these two for loops and we are iterating over the input array twice, and we look for the specific combination where two numbers from the two different iterations add up to a specific target. If you find one, we return it, otherwise we just throw an exception. As we are iterating over the list twice, the runtime complexity of this will be O of n square, and since we didn't use any extra space, the space sum complexity will be O of 1. The second approach is called two-pass hash table. So what we're gonna do is we're gonna acquire some extra space for it. We're gonna initialize a new hash map, and as you know, there are properties of hash map which makes each key to be stored as unique. And the main reason to use a hash map instead of any other data structure is, in an ideal scenario, the runtime complexity of getting an element from a hash map is O of 1. So what we do here is we make two iterations. In the first iteration, we just put all elements in the hash map, and in the second iteration, what we do is we iterate over the array again, and while we are iterating, we check if the hash map contains the complement. Complement of an element will be target number minus number at that index. So we just check if the hash map contains the complement of the number. If it does contain, it means that we have found our required pair. Otherwise, we just reach the end of the array and we don't find any corresponding pair. Now let's take a look at the runtime and space complexity for this. The runtime complexity this time is a function of n, since we are just iterating over the list twice but sequentially, so it is a function of n, not n squared this time. And we are using some extra space which is being used by hash map, which is also n because it's a function of n again. The more number of elements we store, the more space the hash map will acquire. The third approach, which is a slight modification of the second approach, is called one pass hash table. So what we basically do is we just combine the two loops that we had earlier, and now we are putting elements and checking the complement in only single iteration. So yeah, it's modification over the second approach, but with slightly lesser time consumption. The space and runtime complexity will be the same since we are just iterating over the list once, and it's a function of n again, and we are requiring some extra space for storing the hash map. Well, thank you so much for watching the video, guys. See you in the next video.